Okay, so this is a graph of displacement, how you do them, the different forms of motion you get. So first motion that you get is uniform. The second one, simple harmonic motion. Third one is uniform acceleration and retardation. Okay, so first thing you're going to do is you're going to read the guide, what it tells you to do. You're going to read it. So from 0 to 120, it rises 15 millimeters in uniform motion. So from there to there, it rises 15 in uniform motion. From 120 to 240, it falls 30 millimeters, simple harmonic motion. So from there to there, it falls 30 millimeters, simple harmonic. From 240 to 360, it rises 15 millimeters, uniform acceleration and retardation. So from all of this, you could work out where you start. So first one, obviously, is pretty simple. From 0 to 120, it rises 50 millimeters, uniform motion. So you're just going to bring it to 120. You're going to draw a line, join the points up. Okay, done. 2 points. It's very simple. The next form of motion you get is simple harmonic motion. What I like to do is just remember simple semicircle. So from the point it starts to the point it falls, you draw a circle in between there. So the halfway point is your center of your circle. Draw that, boom, got your semicircle. Okay, so now you look here from 0 to 1 to from 120 to 240, it falls 30 millimeters. So 120, 240. You can see you have 4 gaps. Remember that. Okay. Now that know that I have 4 gaps, I know that I need to divide the circle into 4 parts. So using your set square, you are going to divide it. So 1 slice, 2 slices, 4 slices. Okay, so since it's falling, you work down. Okay, so you can label these now if you want, these points. You don't have to, but it can help you if you're really useless. Well, I'm not going to say useless. Let's just say if you're really clueless about this. So 120 starts there, 150 there, 180 there, 210 there, 240 there. So I'm just going to bring these points across. So this one is 150, so I bring it to the line. This one here is 180, bring it to that point. This one here is 210, bring it to that point. Okay, simple. Now that you got all these points, you're going to use your flexi curve and connect all these dots. So start here, you go to your second point, you go to your third point, fourth point, fourth point. And that is simple harmonic motion. It is very simple. The next form of motion you have is acceleration and retardation. I'm not going to explain what that means because I don't even know, but I know how to do it. So from 240 to 360, it rises 15 millimeters. So we know from there to there, it has to go back to the starting point. It goes to, sorry, my brain just died. So from 240 to 360, it rises 15 millimeters. So it has to return to its starting point. And yeah, okay. So what you're going to do is you're just going to divide like a line where you, so obviously because I'm climbing 15 millimeters, I'm basically going up to here. So I'm not going to divide the whole entire line, only that part. Okay. So now that you've divided your line, this is basically the same method you would use if you were dividing or finding dividing a circle into penetration. So I've got 4 parts, once again, divided into 4. So 1, 2, 3, 4. Okay, so now these points don't match. Oh, they do match, they just don't meet. I can extend that line. Okay, so now you got all your points. Create a line to the top from the top one. Now you make you draw parallel lines at each point. Just use sliding set squares. 1, 2, and there. Okay, so there's the line divided into 4 parts. You could use whatever other method, but this is very simple. So now, first thing you want to note is you need to find the halfway point from there. So obviously here it is 300. Okay. So what you do with these lines is you bring every single one of them to 300. As you did with simple harmonic, you can label all these points. Remember, if you're going down, you label down. If you're going up, you label up. Simple. Okay. So at anything that's before this point, before the halfway point, you bring to 240 to the start of the acceleration or retardation, whatever it is. Whatever's after, you bring it to the end. You connect it. So you do this to there, and then you do this to there. Okay, so whatever. So this one obviously is 270. That one there is 300. That's 330. That's 360. Okay, so now what you do is you're just going to once again connect the dots. So it intercepts here. That's your 1 point. There, there, and there. Done. Okay. So sometimes what they'll do is they'll say they'll always give it to you in 30-degree intervals. Well, placing and spacing and that. Sometimes they may say to you from 0 to 45. Okay. If that is the case, what you do is you simply just divide your line, create a new point, and then work from there. So if they said 0 to 45, what I would do is you find the halfway point, however you want it, of this line. I'll just do it like this. And that's your halfway point there, and that's 45 degrees. They wouldn't really give you any other angle besides like 45-degree intervals. That's the worst it will get, but if they do, just find a way to divide it. It's simple. And that is graph of displacements and how they work.